So here we are at 152 to talk about Chapter 10, Enterprise Services. And here we just talk about common software used in the enterprise that is not used by home users. And to do instant response to an enterprise, you have to have some familiarity with how it works. So, shove this around. And let's get the Twitch comments in the back so I can notice if somebody has comments. Okay, good. All right, so first a couple are DHCP and DNS. DHCP is the protocol that distributes IP addresses when machines first boot up. And this means that most portable devices like phones and laptops keep getting a different address every time they boot up in a different room. And therefore, that's really important because the IP address no longer tells you which device you're talking to. And so if it's infected, it's hard to tell which device was infected unless you have good logs of what the DHCP requests are. And the DHCP, when it gives you an IP address, it usually also gives you a DNS server to use. So it controls what DNS server you use. And so you get a lease for some period of time, typically something like a day, and then the lease may be renewed or it may change your IP address after that. All right, so you have to have logs, and what the logs do is they map the IP address to the MAC address. And the MAC address typically is attached to your device. It is not really hard-coded. There's a default MAC address encoded, but you can change it in software. But typically it doesn't change, and so you can use that to identify a specific device. Now, more and more devices are now using a privacy feature that randomizes the MAC address, like especially Macs. So I wonder how good this is. I wonder if a Mac gets a DHCP address and then a week's pass, you may not be able to track it down to that Mac. That's an issue. Anyway, so I wonder how true this is anymore. Back in the days of like Windows XP, the addresses were not random. Now I'm not so sure there's a way to identify a specific device. It seems like you would need there to be. Anyway, so you can search a date for an IP address, find out which system had that address, then search for the MAC addresses, and you'll get all the IP addresses that system had over time. Except, of course, for the elephant in the room, randomized MAC addresses, which I think were not in common use when they wrote your textbook. And I wonder what people have done, because any attempt to fix that will also compromise your privacy. So anyway, I would think in an enterprise you'd want to turn off the random MAC addresses for company-owned devices, but most people are using devices from home, and so there's a problem. Anyway, so you have DHCP logs. You can have a Microsoft DHCP server. This is not a common thing to do because Microsoft software is too inefficient and slow. It's usually better to run a Linux-based one. But anyway, if you do use the DHCP server role on Microsoft server, then it saves a file that has, the IP address, the date, time, and the MAC address, as you'd expect. It also saves the host name, and that might be something you could use if the MAC address is not unique enough. I know Macs used to, by default, have like your name in the host name. It was like Sam's PC. They changed that too a few years back. When they randomized the MAC address, they also changed the name to be random, because they realize all this is bad if you're like in a coffee house and somebody's trying to stalk you. It really shouldn't have something with your name on it. All right, time is local time. This is true of almost all logs, and of course that's a problem if you're a large company spanning time zones. And the logs are only retained for a week by default, which is also very common and also a problem. The default logging is designed for like home users, so it just has enough to do some repair, but not enough for real enterprise incident response, and you'd want to retain it a lot longer for incident response, like maybe a year. And you'd also want to forward it to a centralized log server like Splunk. You don't want to have it stored on the device. ISC, this is the most common. ISC's DHCP, or at least Linux-based ones are common, and the logs go to syslog. Syslog has been a Linux logging facility for decades, and it can send it to various places. You can configure your system to send the syslog to some remote server or store it locally. And so the logs look like this. Here's the log. For the last couple entries, you have the date and time, and then the IP address, and then the MAC address. And I think this is probably the name of the device. So, all right. All right, then DNS is extremely useful. It's been your main tool for decades to monitor what people are doing, because until recently, all DNS requests are made unencrypted over the network, so it's very easy to watch them, and so you know what everybody's doing. You know which device is going to which domain at what time, so you can easily see who's going to game sites, porn sites, malware sites, anything you want, and it's easy to read, not encrypted or anything. Very easy. That's why a lot of people were very upset when people started moving to encrypted DNS, because they lose this extremely effective way to log what everybody's doing at your company. But most people are still using unencrypted DNS, so this will mostly work. So Bind is the most popular DNS server, runs on Unix. It was the original one. There were a bunch of serious Bind vulnerabilities perhaps more than 10 years ago, but now they pretty much got it patched, so it's pretty secure. And it doesn't log by default. You want it to be really fast, but you can turn on logging. Microsoft DNS also has logging off by default, but you can configure it to log. And it just records, as you'd expect, the date and time, the IP address requesting the domain, and what they asked for. And you can have more full logging where it also records what answer the DNS server provided. That's considered more burdensome of your DNS server, but it might be necessary if you want to track down more complicated attacks where they actually spoof the DNS and end up handing out the wrong address. So you can also capture it on the network, not write a log of a server at any time. You can just capture it on the wire as it passes through a router or a switch, as long as it's not encrypted. And so there's a tool just for this called DNS cap, but you could also use TCP dump or anything else. And that's, like I say, it's just standard in many networks, very easy to set up and very powerful. So let's take a look at a Kahoot. I should have them ready to go. There we are, 10A. People in Twitch, we may not get more. That's fine. Maybe they're all off at the protest, so I don't know. That would be nice. But anyway, the customer is always right. All right. All right, so which one causes IP addresses to change? Yeah, DHCP hands out dynamic addresses. All right. All right, which one uses UDP 68? DHCP uses UDP 68 and 69. One of the screwy things if you try capturing it on the wire. You have to get used to that. The really old protocols like DHCP and FTP tend to use network ports in a strange way. It wasn't until later that they learned to use them in a sort of more standardized way. So FTP uses random high-numbered ports, driving the firewall administrators crazy, you know. Anyway. All right, so which one only retains logs for a week? That's Microsoft's DHCP. All right, there you go. Good. And which one came from UC Berkeley? A lot of the internet, basically the whole internet started from UC Berkeley. was a UC Berkeley production, and everybody jumped on board when they saw how great it was. What's that? Oh, yeah, I remember reading that years ago. Yeah, it was an instant response. And I think that was also at UC Berkeley. I'm not sure. Maybe Stanford. Yeah.
It was, yeah.
Yeah. Yeah, but I mean, that's why BSD Unix is the oldest, and Mac OS is based on it. Berkeley Standard Development Unix. Unix was invented by Bell Labs in the 60s, but UC Berkeley made the first one that went big, and they defined TCP and all that jazz, and DHCP and all kinds of things. So the ISC bind was a UC Berkeley production. It became the standard and the only DNS server for a long time. All right, very good. Yeah, this is how we noticed that you don't have a Canvas account. We don't have anywhere to put the points. Yeah, we need to make one. Yeah, well, then you can get your points. All right. And take quizzes and stuff. So, all right. Anyway, all right.
Maybe we need to be on Canvas today.
Yeah. Yeah. If you have trouble, let me know. Anyway, so, let me get this back to showing the Twitch. All right, so here's some more tools that people use in the enterprise. LAN desk, this is real important. In the enterprise, you need to somehow keep track of all the hardware and software you're using. For nothing else, just to pay for the right number of software licenses, this is a big issue. And Microsoft will now force you to install a licensed server if you have a fleet of Windows machines, and they do the same thing for like Photoshop and many other products. And also, even just enumerating your devices, I think I mentioned before, H.D. Moore, the guy that wrote Metasploit, found out in doing pen tests that most companies do not even know what they have. And he wrote a special tool just for that, which is in the projects to just scan your network and efficiently find out what all is out there. Because in these days, everybody's bringing in devices from home, Internet of Things devices. It's actually pretty hard to know what's on your network. Anyway, so software license monitoring will monitor everything your applications do, when they've been running, who's been running it, typically for compliance with paying for it. But this is, of course, useful for incident response too. Who ran this tool, which we discovered as part of the attack. So attackers will often copy hacking tools to a system, run it, and then delete it, and you can record that. If it's a tool like LANDesk, if somebody runs something just once and deletes it, that's suspicious. Normally, if it's an enterprise application, you'd run it every day or frequently. And so that's a clue. And so it'll store information in a monitor log. Each application has a separate key, and so it'll store all the useful information, who first started it, how many times has it been run, and so on. And so you can parse the registry key. Now, there's a browser that doesn't work on exported registry highs, but RegRipper does. To see them. And so you look for things with low total runs. That's suspicious. Anything that's actually in use should be run a lot. Suspicious paths, like run from the recycle bin or temp or somewhere sensible, or downloads, the kind of place where enterprise software really shouldn't be being launched from. And look for your timeline analysis. And here's how you catch living off the land attacks, where people don't use malware, they use standard tools. But typically what anybody does when you first connect is you run the same 4 or 5 tools to get the general information. So net shows you the user accounts. I forget what net1 does. Command, you typically run @.exe schedules tasks, and you run a lot of things. The kind of things you'd often do. Yeah, this is a product to address Y2K, so I don't know if that matters. But anyway, typically when someone connects, you'll see them execute a bunch of commands to show the running processes, the files, the network connections. That's usually what you want, so you can decide what kind of box you're on and where to go next. Suspicious usernames, accounts that haven't run very much, accounts that shouldn't normally be there, and of course, accounts with elevated privileges. You should really know how many of them there are and what they're doing. This is a common technique. The problem with administrator accounts is they can do everything. So then the question is, what if they're bad or they get hacked? You have to have an administrator account review where somebody else monitors what the administrator's been doing. Have they been doing things like creating more administrator accounts, installing unapproved software? You have to have, that's an administrative task, like a management task, to audit what they've been doing. That's right. All right, look for executables that have been deleted. For an installer, that's okay, but for other executables, that's not generally a good idea. And so Altiris is another client that does this for application metering. This records the history of your applications. And so it saves it as a plain text file with all the information. Just another version of the same thing. Executables without version information, that's pretty suspicious. Ones that don't have a signature is pretty suspicious. We've done that in the projects. looking for small things is a clue. Malware is typically small. Commercial software is typically pretty big. And then, of course, there's antivirus that we talk about all the time. Here's a few common antivirus products. It doesn't detect all programs. It only detects the ones it recognizes as malicious. Guess I'll close that door. Maybe not. All right. Anyway, so antivirus is a pretty weak defense because if it flags innocent programs, that's considered really bad. So they only flag something that they know is malicious, like the exact MD5 hash matches a malicious hash. So it will only stop the weakest attackers that would actually send many copies of the same file to many systems. But they're somewhat useful, but you certainly can't assume because the antivirus didn't go off that nothing bad is happening, which is something people often assumed maybe 10 years ago. Now their innocence has been lost and they realize there's a bunch of people living off the land or using custom malware that the antivirus doesn't know about. So you can't assume you're clean just because the antivirus is not going off. But when it does find things, it quarantines them. Now you can't just delete them, but in enterprise situations you want to configure it to quarantine them because you want that sample to analyze it. So it modifies it so it will not run and then saves it somewhere. That's the idea. So attackers often use password-protected archive files, and the antivirus can't scan them because it doesn't know the password. So that's pretty good. It's probably one thing you do with encryption. But they may log errors about them, saying, I tried to unzip this, but I couldn't. That would be a clue that something suspicious is going on. So semantic endpoint protection has extensive log files. It has a strange pattern of timestamps. For some reason, they use the strange pattern. It's kind of annoying. But I don't think there is a Windows standard. There's a Unix standard. But anyway, they do store the timestamp. And the quarantine files, like I say, you modify the quarantine file so it can't be launched. So you change the file extension and maybe do more, and then you save it. And in this case, they encode the file. And in the old days, they would just XOR it with a constant byte of 05A, which is not intended to be very difficult to reverse. It's just intended to make it so nobody can run the quarantined malware by just clicking on it. Now they do something somewhat more complicated, but there is a tool that can extract the files from quarantine, but you have to run it on the system that quarantined the file, which is a little weird. So you obtain the right version, boot up a forensic image of it, or there's a Python tool somebody else wrote, but it doesn't always work. So, people have to get fancy. Anyway, the most important thing is to save it and have some way to reconstruct it to its original form for analysis. McAfee is the famous stuff. John McAfee made it. He was a famous wild man, posted pictures like this, became a lunatic running around, eventually died in prison. But anyway, that's McAfee's still a product. It goes on having cut him out of it. And it saves logs of all the information about the file, the files it's been scanning, and all right. And so the most useful one, the on-access scan and on-demand scan, these shows files that are quarantined or deleted, and it creates events in the Windows event log too. So the quarantined files have a BUP extension, and again, it's been XORed with something just to scramble the bits so it can't be run. And you can extract those with 7-zip, which is nice. And so here's metadata for the pwdump hacking tool, for example, which is something that the antivirus might get. This is something to steal password hashes off a machine. And so you see it records this information about it, where it was, CWindows System 32, and the detection name, saying what they detected it as, so you can Google that and get a write-up of what it is. All right. So Trend Micro Office Scan, again, the same kind of thing. They store plain text logs locally, showing what was detected. Here it is detecting pwdump again. And it has quarantine files again, which are modified, and you can decode them with the tool they give you. So they all accomplish approximately the same good and highly recommended, but they're not enough protection. That's why you need us. You need incident response people, because bad guys are going to get through even though you have these defensive measures. All right, let's try a Kahoot. time, I think we actually got 4, so there may be some more coming. But they might have fallen asleep. Not this time of day, I think. Yeah.
Not this fast.
Oh, I don't know. You never know. All right. Well, let's charge ahead. People can join later. All right. So which one uses this strange 6-byte timestamp? Semantic. I couldn't remember myself. I thought maybe it was McAfee. But anyway, it's semantic. Let's say, yeah. Anyway. All right. Which one puts execution logs in the registry? Okay. Yeah, I thought it was Landesk. I remembered this one correctly. I don't remember them all, but it wasn't Trend, it was Landesk that does that. Anyway. All right. Which one creates BUP files? I guess it stands for backup? I don't know. Yeah, that's McAfee. All right. All right. Which of these is not suspicious? All right. Yeah, all of them are suspicious except for this. This is normal for installers. All the rest of these are strange. Things that you wouldn't normally see. All right. Good. There we go. All right. We've got another section of these, and we've still got time to look at it. Okay, so. All right, then web servers. More familiar territory for me. Those enterprise antivirus things, I don't use them, so I have trouble remembering it. These I use all the time. All right, so your browser sends an HTTP request, which is an unencrypted request asking to get a page or to post some information up, like a username and password. And now these days, you usually use HTTPS, which is encrypted, but the structure is the same on the web server. And so it listens on port 80 for the old HTTP servers that are almost extinct. Now pretty much everybody's using HTTPS on 443, which is much safer. So many websites run on the same server. And if they do, then the IP address is not enough to specify the website. You have to give the host name, and then the web server will say, which web page of the many I'm serving do you want to see? But that means they are all sharing the same hardware and software, so if one of them has a weakness and gets hacked, you might bring them all down. And this tends to happen on shared hosting services like GoDaddy, that a whole bunch of sites get hacked all at once because they're all sharing the same server. So the log files are stored in plain text, and they summarize requests. Who's requesting what, and what did they ask for, and what was the result? Did we serve up that page or give an error message or what? So typically you want to search for requests during a time frame for specific URLs with a certain user agent, and we've done all this in the Splunk section. We did this stuff hands-on. Now, tip for large companies, you don't have just one web server, you have a bunch of them, and then you have a load balancer that sends one request to this one, and the next request to the next one, and so on, so that you can serve more clients, and also so you can scale up in times of high activity so you have more servers, and also so you can stay up even when some of the servers go down. So then you don't know which web server you're talking to. And you may have the load balancer may pass through an extra header just so it can keep internal records of which server this was sent to. So that you can log that, and then you'll know which header is being used. If you don't log that, and there's a problem of some kind, like somebody puts malware on a server, you're not going to know which server they put the malware on, since you have several identical servers running. Web content, you typically alter files on the web server. That's the common old attack where you deface the web page. Or you can upload tools like web shells that give you remote control of the server, or hacking tools. And what people typically do is get like standard PHP hacking tools. You just download them and use them. You could write your own, but most people don't bother. There are popular ones, and there's often news articles about the latest info stealer or remote control client that's trendy right now that everybody's using. So here, there's a lot of obfuscated PHP out there. It looks like this, these long random letters for everything. And then you define something like, what they do here is they define a string called OI-OWL that is a whole bunch of random letters, and then they take the letters, the 20th letter, the 21st letter, the 71st letter, the 84th letter of this string. So this is going to add those letters together to create a command. The command itself would be suspicious and set off your antivirus, but doing it this way, it can't figure out what it's going to do. So this is common obfuscated PHP. And by the way, it's not always malicious. One web design trick, which used to be very common, is you just go to somebody else's page, you view the source, and you steal that code and put it on your page. So people would do this to make it harder to steal their code. So it might just be an anti-theft measure, but of course malicious PHP is often obfuscated this way, and there are online de-obfuscators to just uncomplicate this stuff. So Apache is the most common web server because it's free and open source. It's used by small businesses and individuals. Large enterprises use Microsoft products because they need all the other Microsoft features. So there are several configuration files that all work together to define the configuration, which is pretty annoying. You often have to hunt through them to find which one is controlling the configuration. And you can also have HT-access files available to do things like put a password on a certain directory. And it makes log files, the typical var log files. And you have to add this if you want to log the X forwarded 4 headers. So here's a log entry. Somebody tried to get this text file, and they had this user agent, and it got a 200 result. So they succeeded and got the file. And 1330 is probably the number of bytes transferred. So also you have the IP address of the source. So basic information: who's been downloading files off my server. So if somebody was, for example, doing a brute force login attack, you'd see a whole bunch of posts from the same address multiple times per second, like we did in the Splunk part. This is where it comes from. The log file will log each attempt to log in, followed by an error message, and that will be your clue that somebody's doing something bad. So you have a special place you put stuff, typically var, www, HTML. You can change it, and might have things like server root or docker root have that in configuration file that specifies where it goes. And then there's Microsoft's web server, IIS. All the server versions of Windows can run this, and it's commonly run at large companies or Microsoft shops. And it has a config file that specifies an ID number someplace at the end of the log directory name. So your log, you have ID 1. So it stores your logs here in INET-pub logs. INET-pub is where Microsoft likes to store internet information. So the log files have the date, and then advanced logging places files in a different directory. They are included with UTF-8 because everything about Microsoft is designed for international use. So it supports all commercially important languages with their version of Unicode. So it looks like this. Here's a log file giving you the header. And so you've got date, time, source IP, client IP, the method, the URI, and so on. So here's an IP address. It sent a post to this file on port 443 with that user agent. And there's some information here about the time and the status and so on. So the same kind of information you'd find elsewhere. All right, so those are web servers. Then there's database servers, which are very high-value targets typically because they're full of credit card numbers and other things, sometimes usernames and passwords and so on. So Microsoft SQL, of course, the large companies use Microsoft everything. And so you'll have the attacker's IP address. You'll have logs of errors, which is what you often look for attacks, because when you're doing like SQL injection, I do it all the time, you typically have many wrong ones before you get it right. You have trouble getting the right punctuation, the right fields and everything. So there'd be a bunch of logs of malformed queries before you actually have a good one. Your query logs, however, are often not enabled. To make the database server faster, they don't log every query. So this is something you do only if you're suspicious. The database is typically huge, stored on some kind of storage attached network or something with many devices working together. And we talked about this about instance. Usually copying the whole database off the database server is just ridiculous. You have to find a better way than that, like just getting log files, because it's far too much information. And you don't work on a live DB is not good because that's being used. So you want to work on some kind of copy of the information, hopefully just the logs. Of course, this is a thing to be aware of. Your incident response activities might crash a server and bring things down. And it usually involves interrupting business because usually the first step is to quarantine the affected systems. So you move through some part of the business stops operating as you quarantine some of your devices to try to stop the infection from spreading. All right, so Microsoft SQL has a free version and a commercial version. It doesn't log connections by default, only failed connections. So you probably have to turn on more logging if you want to have enough information to be useful. Here's an unsuccessful and then a successful connection attempt. So here's login failed, here's login succeeded. And it would be nice to support them both, but of course the more important one are the ones that fail because those are likely the attacks. You can log, again, it doesn't log queries by default, but you can turn it on. But if you do, you will not be able to handle as many requests per second. And typically your database has a lot of action. You have a bunch of employees at your company putting in orders and stuff, and the database is where all the customer orders and customer addresses and everything are. So that's why people are usually reluctant to turn on a lot of logging because their server is busy. So preserve your evidence. You could make a forensic image of the drive, but that requires taking down the database server and then making that copy of the huge database, which is probably not important. You could copy these files. There's a tool called SMSS that can back them up. In MySQL is common. Oracle bought it, but the open source fork MariaDB became popular. It's still around. And they have a configuration file with general information in it specifying how much logging to do. And typically only errors are logged, but you can turn on more logging if you're willing to accept more processing overhead. So general look at root connected from this address and executed this query. If you're logging queries, you'll get all that information. Here's the timestamp. That is, I suppose, the date. And here's where they came in. Here's the query they executed. So, you know, that's nice information if you can have all that. And so you can shut down the server gracefully and image the hard disk. You can stop the MySQL service and copy the files. You can back it up. These are ways to back up the database itself if you want to. And Oracle, of course. Like Larry Ellison, really famous billionaire. Now he owns TikTok. And Oracle is widely considered an extremely unethical, nasty company, but they're big with mega. They're very important. A lot of people use them. This college uses them. Practically all large companies use Oracle databases. They are considered the best and often considered the most secure for really big companies, but really expensive. So a lot of local governments paid $1 million for an Oracle database, and then they said, you know, we could have got by with something cheaper like Microsoft's database. Anyway, it's around, and it does log things like the others. At this college, they used to have Oracle training classes that would get your Oracle certification. And like 10 years ago, they said that people would get jobs, high-paying jobs quickly if you get the certification because it's pretty hard to use. I don't know if that's true anymore, but certainly you can get certification and be qualified to run Oracle, and that puts you in a small group of people that are qualified to run it. You can't just quickly figure out how to run it. You really need to take courses and certifications. It's complicated. Anyway, so here's a successful connection to an Oracle database. Connect. And established, I guess, is what this is. And Bob is username, so you have some information. And you have an IP address, which I guess is the client connecting, although I'm not, and the port number. So anyway, does not indicate success or failure. Well, that's rude. But anyway.
Does establish indicate?
Well, that's what I thought. Yeah, and they say, anyway, you have to turn on auditing, which is, so I guess this is with auditing turned on. I guess established means it's connected. Anyway, you'd have to read the documentation to find out exactly how to understand this. But those logs are useful, but like I say, relatively expensive. So most people don't leave them on all the time. Anyway, let's try 10C. free open source software? Apache, all right. A competitor to Apache that's picking up is Nginx, which was originally written by criminals to run bot farms in Russia. And originally the documentation was only in Russia, but now it's gone commercial and it's considered far more effective, far more efficient than Apache. It's a stripped down version of Apache to handle like millions of connections really fast. Anyway,
Wow, that's interesting.
increasingly popular. Yep. All right. So which one conceals the IP addresses from server logs? The load balancers have that effect. Your server is going to just see all the requests coming from the load balancer. They're not going to see the address of the client that connected to the load balancer unless you configure it to pass that through. All right. Same thing's true of Cloudflare, a reverse proxy. You will lose information unless you configure a special module to pass that information onto your server. Because people are not connecting directly to your server, they're connecting to a proxy which connects on their behalf. It amounts to the same thing. All right, which one is free but not open source? Express used to be Microsoft's word for this, like Outlook Express as a free. I wonder if people are still using SQL Server Express. I never used it. But anyway, that was the free version of Microsoft SQL Server. It might still be around. They might have renamed it by now. Probably called it 365 or something. Anyway. All right, a tool used to manage a database server. Oh. I didn't notice this in the slides, but it's true. I remember using it in Microsoft courses. Yeah, SQL Server Management Service. Microsoft has special tools to manage these things, also special tools to run the updates and such. Anyway,
How does JR know all the answers?
yeah. Oh, yeah, must be. Anyway, so which logs? Connection by default. Which one? Oracle does. Okay, that's interesting. Okay, because usually none of them want to, but I guess Oracle does have some logging information by default, not complete logging information. Anyway. All right, so